Okay, I'm starting where I left off last time. This is how to simulate a triangle wave in LTSpice. In my previous video I did a square wave, and there's a lot of similarity between the square wave and the triangle wave. But again, I'm going to change my frequency, my voltage, and go ahead and go from there because this is what I'm using to build the waveform, if you will. So I'm going to pick a frequency, and I'm going to pick 876 hertz, and I'm going to make it a 4 volt peak to peak. So 4 volt peak to peak voltage is 2 volts peak, and for triangle, the volts peak to RMS conversion is half, so it's 1 volt RMS. I'm going to have a minus 1.5 volt offset. So anytime you get a new frequency, a new waveform, you got to go through and calculate some stuff. Now the frequency, I had the spreadsheet automatically turn into the period by just taking the reciprocal. And so I'm looking at this and I'm thinking 0.011415553. So let's round that to 0.0011. So I'm just going to round it to some number, 0.0011. I don't want the 4. Let's go ahead with the 4. There we go. Okay, now my sample time is 1/10. So I'm adding a 0. I set the spreadsheet up to do that for me. My delay time is twice my period. So that's set up to figure for me. Number of waveforms, this time I only want 2. So I'm going to go from 228 to 456. So it's going to start after 2 waveforms, and it's only going to run for 2 waveforms. Now I want a triangle wave, and to build a triangle wave in Spice, your rise time and fall time are your triangle parts. Your time on is going to be very small, and then your duty cycle is your entire period of the waveform. So in this case, my duty cycle is the same as my rounded frequency. So that should be 0.00114. Okay. Now, once I have the duty cycle, I can establish my time on as I usually like to do a small fraction, so 0.00001 is my time on. Okay, and what I'm doing here to get that is I'm taking this duty cycle here, and I am saying, okay, my on time is going to be a very small fraction, one little point of that. And then my rise time and my fall time will be the angle. So they're going to get long, and my time on is going to get short. This is exactly opposite from the square wave, and you'll see the effect in a minute. So 0.00001. So that's 4 zeros and a 1. So let's make that happen. 0.123. Whoops. Changed cells on me. 0.1234 and a 1. 1, 2, 3, 4 and a 1. Okay. Now my fall time, I'm subtracting 1 from my time on. I'm going to subtract 1 from my time off. So that gets me down to 0.00112. And if I divide that in 2 for my rise time and my fall time, half of 112 is, I can just divide this by 2, so I can just subtract 2. 0.1234 2 and I can make it negative. Enter. I can do the get the spreadsheet to do the math. You're less likely to make a mistake. And then this divided by 2 is what I want. My rise time. So 0.00056. So my rise time then is 0.00056. Enter. My fall time will be the same. 0.56. It's very important if you're building square waves and triangle waves that you get them perfectly symmetrical. So yeah, the period's not perfect, but we're going to get there. And then this is what I'm going to put into LTSpice for my rise and fall time. So now I got to go into my LTSpice circuit and I got to build it, or I've got to modify it. This one, as you remember, is just doing a square wave. So I got to change 2 parts. I've got to go in and edit my pulse. And I'm just going to make everything a 0 and start over. And you do use a pulse for a triangle. You do use a pulse for a square. So here we go. Blank those all out. And if you get multiple problems on a worksheet, you're going to have to do this. You're going to have to blank it out or go with a new spreadsheet. Maybe I can make that to where I can see everything. That'd be sweet. I'm shortening it, but I can see. Okay, I want a on voltage and my off voltage. So it's going to be offset 1.5, and it's going to be 4 volts peak to peak. So when it's on, it's going to be 2 volts above that. So my on voltage will be 0.5. My initial voltage will be minus 1.5 plus and 2 below that, so minus 3.5. Okay, so this is going to give me my peak. Consider your V initial your bottommost part, or your negative peak, and your V on your positive peak, and then you adjust it by your offset. I'm not going to have a delay. My time rise I figured out is 0.056. My fall's the same. My time on is very small. That is 4 zeros and a 1. And again, you can put these in millis. The total of my period is 0.00114. And my number of cycles, I'm going to do 2 before I start saving. I'm going to look at 2. I always add 1. So I've got 5. So then I'm going to click OK. And that changed my pulse parameters in my Spice. Now I got to go in and change my tran parameters. So I go up to simulate, edit simulation command. My start time and stop time and all that stuff changed. And can I see it? Yes. So my stop time is 00456. 00456. My time to start saving data is 00228. And my sample time is 1/10, or 3 zeros, 114. So that will be my sample time. Now I click OK. So I have to change my pulse generator to make it look triangular. I have to change my transient analysis. Let's spread this back out. Yeah, let's get back out to the edge because all it's doing is hiding it. And now I can simulate and run. And I want to look at the top of the resistor with respect to ground. And there is my two triangle waveforms from -3.5 to 5. Well, 0.5. -3.5 to 5. So it's got the 1.5 volt offset. It is 4 volts peak to peak, 2 volts peak. So I've got a real pretty sawtooth going there. And that's my triangle waveform. I hope this helps. It's always good to do some calculations, and as you work it out, put in the formulas, whatever, and then you can start with the frequency and the voltages. You got to keep the voltage types straight, the offset. If you're doing square and triangle, you got to do rise, fall, duty, time on, and duty cycle. And for transient analysis, you got to come up with your sample time or max time between steps, they call it, the start time for keeping data, and the end time. So all that changes if you change the frequency and for every waveform. But if you'll do that, you can get consistent results. You can basically simulate any waveform that you can be given. And that is the purpose. Thanks for watching. Have a great day.